We as a species are on the brink of becoming interplanetary, with manned trips to Mars and beyond on the cards for just the next few decades. However, with current trips to Mars taking upwards of 7 months to complete, it makes me think, there has to be a better option out there, right?
Currently, we use chemically powered rockets, which use chemical reactions in the engine to push out exhaust and propel the rocket forwards using Newton's third law. These rockets do produce a decent amount of force, which we call thrust. However, they're not very fuel efficient, as measured by their specific impulse, which is the thrust they produce divided by the weight of the rocket's exhaust. This poor fuel efficiency makes it difficult for them to carry large payloads and to travel into deep space quickly. And so if we want to make interplanetary space travel more common, we need a better alternative.
And this alternative may come in the form of something called nuclear energy, which we produce by either nuclear fission or nuclear fusion.
Nuclear fusion is what powers all of the stars in the universe, and includes two atoms smashing together and fusing into a heavier atom, releasing a lot of energy. Fusion-powered rockets would have an incredibly high specific impulse, of around 130,000 seconds, but unfortunately, we haven't yet developed the technology to sustain such a reaction. And so the other option is nuclear fission, and is the main method used by nuclear power plants here on Earth today. In fission, a neutron is fired at high speeds at a larger atom, typically a radioactive one, such as uranium, and causes the nucleus to split into smaller parts, releasing a lot of energy and sending more neutrons out, triggering a chain reaction. One of the main fission-powered engines we are currently working on are nuclear thermal engines. In a solid core nuclear thermal engine, the nuclear reaction occurs in the reactor core, which produces a lot of energy in the form of heat. Liquid hydrogen is then pumped into the reactor core, which both cools the reactor and also causes the heat to be transferred to the hydrogen, which makes it rapidly expand. The liquid hydrogen is then shot out of the nozzle at high speeds because of this expansion, which then propels the rocket forwards.
Now, there are some slight disadvantages to this engine, such as the fact that as a fuel, liquid hydrogen is a bit difficult for us to store right now. However, if we were to make nuclear thermal rockets a reality, they'd have nearly double the specific impulse of a chemical rocket, and allow us to get to places such as Mars in as little as 3 months.
This isn't the only way we can use nuclear-powered rockets as well, as nuclear electric rockets are another type we're currently developing. The energy produced from the nuclear fission reaction would be used to produce electricity, which would then power an ion thruster, which itself just sounds like science fiction. This thruster uses electricity to propel positively charged ions out at incredibly high speeds. And while these ion thrusters may not have a high thrust, they do have an incredible fuel efficiency.
Nuclear energy poses exciting new possibilities for the future of space travel. And if it continues to be developed, who knows? Maybe one day we can vacation on Mars.